This lesson will cover the use of scientific notation. Scientific notation can be used for very small numbers or for very large numbers. It's useful because it avoids the use of lots and lots of zeros in our values, which can often be hard to keep track of. When we are writing a number in scientific notation, we use the exact same format every time. We have a number, so we'll have an example, 3.5 times 10 to the fourth. When we look at this value, notice that there is only one digit to the left of the decimal place. There can be as many as digits after the decimal place as we need. Then we put times 10 and then we use our exponent. So let's look at a couple of examples to see how we get numbers into scientific notation. So when I look at my number here, 459,000,000, instead I can write this as 4.59. Notice that I have one digit to the left of the decimal place, and then I'm going to put times 10. But I've got to figure out what my exponent needs to be, so I'm going to count the number of decimal places that I moved the decimal point in writing it in scientific notation. So starting here from the right, because there's no decimal point there, so it's implied. So I have 1, 2, 3, 4, 5, 6, 7, and 8. So to write this number in scientific notation, I say 4.59 times 10 to the 8th. I move the decimal point to the left, therefore my exponent is positive. Now let's look at the second example. I have 0.000000513. I start out the problem the same way. I write one number to the left of the decimal point times 10. I still need to figure out how many decimal places I moved over, and so 1, 2, 3, 4, 5, 6. And it's 6 places, but because I moved it to the right, it's going to be a negative 6. Whenever we have a positive exponent, we know that the number is going to be greater than 1. If we have a negative exponent, the number is less than 1. Notice that both of these are positive values. If one were a negative value, then we would have a negative sign in front of the number. The exponents simply tell us which way to move the decimal point. To better understand the format of scientific notation, let's look at a couple more of examples in a little bit different way. First, we're going to look at the number 2400. Notice that I can rewrite this number as 2.4 times 1,000 because those are equivalent, and 1,000 is the same as saying 10 times 10 times 10. So we can look at this in a kind of an expanded form and see where we can get the 2.4 times 10 to the third. So this value that we've written here at the bottom means exactly the same thing as 2400, 2.4 times 1,000, or 2.4 times 10 times 10 times 10. Similarly, we can look at dividing by a number in order to get the number with a negative exponent for scientific notation. So here, 8.6 divided by 10,000 is the same as 0.00086. We can say 8.6 divided by the result of 10 times 10 times 10 times 10. And we can also rewrite this as 8.6 times 10 to the minus fourth. Notice this is consistent with what we saw in the previous examples of moving over 4 decimal places. When you're entering numbers in scientific notation on your calculator, you need to make sure you use the correct format. Note that many calculators have a button labeled EE, or sometimes it's labeled EXP, and that button means times 10 to the. So you don't need to type in any of this part. So when it says 4e to the 6 on the display, or 406, variety of ways you might see it, that reads as 4 times 10 to the 6, even though the times 10 is not explicitly shown. Different calculators function in different ways. If you have questions about how to use yours, please come see me. How should you write this number 0.00382 in scientific notation? Hopefully, you got the correct answer as D, 3.82 times 10 to the minus 3. Remember that when we write a number in scientific notation, there is one digit to the left of the decimal point. We write times 10 to the, and our exponent is determined by the number of decimal places we move the decimal point. For this number, we moved it 3 places, but we also noticed that we moved it to the right, and this number is less than 1, so our exponent is going to be 3.82 times 10 to the minus 3.